on the circumference of a circle. So we're looking here, in this picture we're looking between these 2 points, and we're just taking this piece of the circumference. Now because it is part of the whole circumference, we are going to add on a fraction to our circumference formula. So the arc length formula is the degree of the angle that's formed by the arc divided by 360, because there are 360 degrees in an angle, and then we multiply that by the circumference formula, 2 pi r. Okay. So when I look at example 4 here, I'm going to take the degree, and that always goes as part of the fraction. So this is a fraction over, a degree over 360 degrees. And then we multiply that by 2 times pi times the radius, which is 6. So the angle measure goes in the fraction, and the side length goes in the circumference part of the formula. All right, then you can take that and plug that into your calculator, just like you see it written out here. So you would use 315 divided by 360, or use the fraction button, and then times by 2 pi, and then times by 6. And you should get about 32.97. Now, I am using a 3.14 to estimate for pi, but you can use the pi button on your calculator, and you will get a little bit different answer than me, but it should be really close. So the next question, what is the length of the arc formed by a 30-degree angle? Okay, and we're talking about a length and a radius of 5 feet. So the degrees, or the angle, goes in the fraction over 360, because we're talking about degrees, multiplied by 2 pi times the radius. So we take that and type that into our calculator. And I got 2.62. So it's just over 2.5 feet to go 30 degrees around a circle that has a radius of 5 feet. Now we're going to take this idea and apply it to a problem that doesn't use degrees. So suppose you have a clock with a 3-inch radius. Okay, here's my clock. It's a 3-inch radius. What is the length of the arc between the 3, that would be right here, and the 4 right here? So I'm looking at this point, this arc right here. Now, we don't have degrees, so we're not going to use degrees over 360. We do know the circumference part of this is going to be the 2 pi times the radius. So this will be still be 2 pi times 3 for the 3-inch radius. And for our fraction, we're going to have to make a new fraction. So when I look at a clock, it is already divided into 12 segments. So instead of using 360 degrees, I'm going to use the idea that the whole clock goes through 12 sections on a clock. And the number of sections between 3 and 4 is 1 section. So this would be 1 section out of 12 total sections times 2 pi times the radius. So that tells me that the distance between the 3 and the 4 is going to be about 1.57 inches. All right, so that is arc length. So you can go back to your assignment now and finish your assignment out. Just remember that degrees always goes in the fraction, and the side length should go where the radius is. If If you have additional questions, you could review the video from Mr. Burrell that's also shown on the Canvas page, or you can work with each other to get some help, and I will follow up with you guys tomorrow.